Good day. Welcome to today's virtual reality lesson. We will be discussing the linked list data structure. My name is Jarvis and Alice, and I will be guiding you through this visual demo.
Hi there, I'm Alice. This tutorial is intended to be viewed through a virtual reality headset. Before proceeding, please find a comfortable space to stand or sit in. Although no walking is required, be sure you are clear of any hard or sharp objects in your physical reality, in the unexpected event that you move.
If you are instead watching on a traditional screen, you may click and drag the frame to change your perspective. We will now begin the tutorial. In this tutorial, we'll be using a singly linked list, where only one pointer is used between each node.
We will also represent pointers with black arrows, and we'll represent nodes with blue boxes. Lastly, if you look up, you can see the line of code that corresponds with the current operation being shown in the diagram.
To start building a linked list, we will first make a head pointer to hold on to the front of the list.
Then, we'll create our first node. We will also make a current pointer. This will allow us to move along the list.
Using our current pointer, we'll move to the next position, which currently points to nothing.
This is also commonly known as pointing to null. We will now create a new node at the current position.
Once more, we will step to the next position and also make a new node at the current pointer.
Awesome! We have now just constructed a linked list with 3 nodes.
However, let's suppose we want to insert a new node at position 2. How would we do this?
Well, since in a singly linked list, the pointers only point one way, down the list, the only way we can go backwards is by resetting the current pointer to the front of the list. This is why we have left the head pointer at the beginning of the list.
Right. Next, we step up to the index just before position 2, which is index 1.
Now we create the new node we want to insert, and hold onto it with a temporary pointer.
To begin integrating the new node into the list, we set the new node's next pointer to the node at index 2.
And we set the next pointer of the node at index 1, to temp.
Good, we have successfully inserted a new node at position 2. Good job, Alice, we've done it again.
Thank you, Jarvis. Another thing to add, there are different ways that can achieve this result. So keep in mind this isn't the only way.
Right. Now, let's suppose we want to remove the node at index 1.
To do that, we can start by setting the current pointer to the node just before 1.
And set a temporary pointer at node 1.
Next, we set curs next to temps next. This skips the node in which we wish to delete.
Lastly, to prevent a memory leak, we delete the node held by temp.
Cool. We have successfully removed the node at index 1. Great job, Jarvis.
Thanks, Alice. This concludes our simple demo on linked lists. Be aware that there are other variants, like doubly linked lists.
Additionally, there are other operations besides insert and delete in which you may wish to research for linked lists as well.
We hope this has given you some intuition on how linked lists work. Again, my name is Jarvis, and Alice, and I hope to see you again in the next demo.
Please carefully remove your headset as you may have drifted position during the tutorial.
Have a wonderful day, and
goodbye.